Hey everyone, in this video we'll be solving this problem from Pathfinder Check Your Understanding from the kinematics topic. In the question, there's a large slippery ground on which a boy left his dog sitting and walks away with a constant velocity of 2 meters per second. When he is at a distance of 199 meters away from the dog decides to catch him and thereafter move together. So the dog cannot develop acceleration more than 2 meters per second square in any direction. So in what minimum time will the dog meet the boy? So the situation is something like this. So the dog is over here somewhere and the boy is currently at a distance of 199 meters and is moving towards the right with a constant speed of 2 meters per second. And now at this instant, the dog starts moving as well and he needs to reach the boy. So we need to find the minimum time the dog will take to meet the boy. Taking the frame of reference as the boy, so then we have to reverse this velocity and add it to this dog. So this dog will have a velocity of 2 meters per second in the leftward direction as it is in our diagram. And now let's draw the VT curve, the velocity time curve for this dog in this frame of reference. So initially the dog's velocity is minus 2 meters per second. So this modulus will be 2. And then his acceleration is going to be, and let's say his acceleration, he'll start accelerating towards the boy. But after some time, he needs to start to decelerate as well. Now, if you add up the displacements, which is the area under the curve, you should get the answer as 199 meters. Why is this particular case the minimum time taken? Well, it's because the maximum rate at which the dog can accelerate is 2 meters per second square. So he's putting all his efforts to, increase his speeds, and then he puts all his efforts into decelerating till he reaches the boy. And that's why this is the condition for minimum time. So now if let's find out the area. So the slope of VT curve gives you the acceleration. So the slope of this line is going to be 2 meters per second square. With that, and hence we can say that this time is going to be 1 second, right? Because 2 divided by 1, it will be 2. So hence the slope is 2. Let's say the base of this triangle is t seconds. And the height of this triangle, again, we can use the slope formula. If this is theta, then tan theta has to be 2. Now this length is going to be t by 2, which means this height is going to be t by 2 tan theta. So the area of this triangle is going to be half the base, which is t, times the height, which is t by 2 tan theta. And the value of tan theta is 2. And this minus the distance of this small triangle. And why are we subtracting it? Because the displacement is negative, right? Because the area is negative here, and which basically means the dog travels to the left for a while. It's going to be half into 2 into 1, which is just 1. And this should all add up to 199 meters. And after solving this, you'll get the value of t to be 20 seconds. Now, as t is 20 seconds, so the minimum time taken by the dog to reach the boy is 20 plus 1, that is 21 seconds. So that was it for this problem, guys. So moving on to problem number 2. So this is problem number 35 from the Build Your Understanding section. So in this problem, we have a boat that is moving with a velocity of 20 meters per second towards the left. And it's pulling a water skier with the help of a tug rope of length 10 meters. To increase his speed, the water skier tilts the skis slightly away from the direction of motion of the boat, something like this. And as he does so, the tug rope rotates. What is the speed Vs of the skier with respect to ground? So we have to find this magnitude of this Vs, and we also have to find the angular velocity of the rope. It's given that the theta is 30 degrees and phi is 60 degrees. So now it's clear, as the rope is pulling this guy, its length has to remain constant, which means the velocity at the endpoints. So let's mark these 2 points as A and B. So the B point moves at this angle, at an angle of phi. Velocity of Vs at an angle of phi with the rope, and the A point moves towards the left, and the angle the rope makes with the horizontal instantaneously is 30 degrees, and this velocity is 20 meters per second. As the length of the rope cannot change in this particular case as it is under tension, we can say the components of velocities at the endpoints along the string has to be same. So we can say 20 cos 30 equals Vs cos 60, as these are the components of the individual velocities along the rope. If you find out the value of Vs comes out to be 20 root 3 meters per second. Now we have to find the angular velocity omega of the rope. So let's say if we have a line OP whose perpendicular component of velocity at this end is V1, and whose perpendicular component of velocity at this end is, let's say, V2, and the length of the line OP is L and it's constant, then we can say the omega of the rod OP is V1 plus V2 divided by L. The perpendicular component of velocity of 20 meters per second is 20 sine 30, that is 10 meters per second. And the perpendicular component of velocity at this end is going to be 30 meters per second. And the length of the rope is given to be 10 meters. So we can rate the omega of the rope 30 minus 10, because this 30 will try to rotate it in this sense and the 10 will try to rotate the rope in this sense. So we have to subtract them, divided by the length of the rope, and it comes out to be 2 radians per second. So that was it for this video, guys. If you have any queries, you can comment down below and like and subscribe for more content. Thanks for watching.